So we're going to start with dot plots, which is a graphical way to represent your data. So here it says, how long does it take you to eat breakfast? So 6 people said 0 minutes. Those people probably didn't eat at all. So I need to make 6 dots above 0. 2 people said 1 minute. 3 people said 2 minutes. 5 people said 3 minutes. And when you're making these, you want to make sure your dots are roughly the same size and the same space apart. Okay, it's important that you're consistent so that you get an accurate picture. 2 people said 4 minutes. 5 people said 5 minutes. Got 0, 0, 2, 3, 7. 4 people said 11 minutes, and 1 person said 12 minutes. All right, bar graphs and histograms. Bar graphs are used to display categorical data. So usually something that's not a number, but fits into a category. So if you collect data on pets or favorite type of ice cream, all of those are categories and they don't have a number assigned to them. So we use bar graphs a lot for those. Okay. So here in this example, they're talking about different types of donuts. Students were asked to name their favorite cookie. The results are as follows: 5 sugar, 6 raisin, 8 chocolate chip, and 2 oatmeal. Okay, it might be helpful here. In fact, I'm going to go ahead and draw in some light lines for my different numbers, because as you go across, it's harder to keep them all the same. Okay, so again, you might want to sketch in some light lines too, but it's not mandatory. There are 5 people who liked sugar. So for my sugar, I need to go up to 5 and make a bar. Now this is why I think the lines are helpful, because it's hard to like go straight across without a line. A lot of people will go a little bit up or a little bit down as they go across. 6 people liked raisin. There's that. 8 liked chocolate chip. You want to try to make sure your bars are about the same width, because if you make one thicker than the other, then it can be misleading. And then oatmeal was 2 people. And again, we're human, we can't make everything perfect, but you want them to be the same width and straight across from their number if at all possible. Okay, so that's our first page. We talked about a dot plot and a bar graph. Histograms are very similar to bar graphs. In fact, they often get confused with bar graphs. Bar graphs typically have space in between. They don't have to, but they typically do. They could be all squished together. Histograms never have space in between because it's continuous data. Also, we use bar graphs typically when there's a category. Histograms always need numbers. So you could make a bar graph of numbers, but instead it'd be a better choice to make a histogram. So number values are for histograms. This example is talking about weight, because there's obviously weight is assigned a number and people can be anywhere within that spectrum. Here's data that has been collected in intervals of 30 pounds. Okay, so that's still this example, and that's called your bin width. So here you're going from 90 to 120, 120 to 150. Each category, each bin is 30 pounds difference. The difference in a way that bar graphs and histograms are drawn is that the bars and bar graphs are usually separated. We talked about that. Histograms are next to each other. They never have space in between. So the first thing we're going to do, in this case, our bin is 10%. All right, so I am going to tally how many grades I have that are between 50 and 59. So if we go through our list here, we've got 1, Or here, we can just start at the end. 82 would go in this bin, 79 in this bin, 90, and so on. And we're going to be doing a lot of data in a list that's not organized. And I really would suggest that you cross off things as you go because it's really easy to get lost and lose your spot. All right, so there's our tallies. I'm going to go ahead and pause and draw in some lines like I did for the last one so that you don't have to watch me do that. All right, so again, I just drew in some light pencil lines to make sure that I do things straight across. It's not mandatory, but I do think it's helpful. And then our frequency would go from 1 to 6. Because the most tally marks we have are 6. So when you're making your bars for a histogram, instead of making one right above, you make one halfway in between your bins. So our bars are going to end like in these halfway sections. And they're going to connect. So 50 to 59, I had 1. I'm going to start on the edge and go until I hit there. Then 60 to 69, I had 2. 70 to 79, I had 3. Then I had 4. And for the last one, we had 6. So again, these pencil lines are not mandatory, but I think they're helpful, especially when you get way over here, because without this line, it's really hard to get those even. Again, make sure there are no spaces on a histogram. Stem and leaf. So in this case, we're saying that the stem is the first digit and the leaf is the second digit. There are cases where you might reverse that, which is why you want to have a key. So here, when you say 4 with the line in between and then 1, that means 41. But I could have a different key. Like let's say I have 5 and then 1 means 5100. Okay, so you do need a key because they could mean different things. So practicing with our stem and leaf, you have to put these in order. So again, this is where I would highly suggest you cross things off as you go. So it looks like 45 is our very smallest. So on my row of 4s, I'm going to put a 5. We'll say like 7/3 means 73. So this is your tens place and your ones place. And again, don't forget to fill in those keys. I don't think I have any 50s. It looks like I have a 67. So I'm going to put a 7 here. For our 70s, it looks like the smallest one is 72. So I'm going to start with a 2. We have a 78, 2 78s. So you have to put 2 8s, 1 for each. Okay, and you put commas in between. For our 80s, it looks like 82 is the smallest. Then we have 86, a couple of 88s, and a couple of 89s. Then for our 90s, we have 90s the smallest, 91, a couple of 93s, 95, and a couple of 99s. And then lastly, we have 2 100s. All right, so this is what our stem and leaf would be for that type of problem.